Hello, this video will explain problem number 44 in chapter number 7. You have two billiard balls of equal mass colliding with each other, and they had an x and y components separately. So B was moving with x and a component of momentum, and A was moving with a vertical momentum. And they only tell you that the billiard B is moving with a vertical momentum afterwards. Okay, so let's go ahead and make sure you understand that. It already is drawn in your book, but maybe you don't have the book in front of you right now. So this is going to be MB, and I said they have equal masses, so I'm just going to write M, and this is MA. I'm just going to say that equals M. Doesn't really matter if they equal. And then this goes up, and this is MB, still has the same mass. And then MA, we don't know where it's going. I'm just going to show it going to the right. And we're going to have MA equals M. We don't know the final velocity of B. We do not know the final velocity of A. We know the initial velocity of B, and I'm going to say going to the right and up is positive, so that means that my initial velocity of B is a positive 3.7 meters per second, and my initial velocity of A is a positive 2.0 meters per second. Okay, now some of you might be thinking that you need to use the equation from page 176, and that's not the case. Okay, so first thing we'll do is just take a look at it from a momentum perspective, taking the equations that I've shown you before. So in the x direction, you're going to have m b v b initial in the x plus m a v a initial in the x equals mb v b final in the y plus ma v a final in the y. Why did I change it to the y? Oh man. Okay, those two y's should have been x's. So you got, sorry, all x's, all y's. So let's jump into the last equation. So then we're going to have we're going to look at the momentum now in the y direction. Okay, so we're going to have mb v b initial in the y plus ma v a initial in the y plus, let me zoom out, not plus, equals mb VB1 in the y, so final in the y, plus MA VA1 in the y. Okay, so we have our x's, and highlight it. You have all your x values, and you have all your y values. Okay? Now, you should be able to realize that all m's, all the masses are just m, so just cross them out. They're going to just cancel each other out eventually. Okay? So no mass. Because if you divide it, you can divide all by m, basically, is what I'm saying. So then this x equation would just be VB initial in the x plus VA initial in the x equals VB final in the x plus VA final in the x, and VB initial in the y plus VA initial in the y equals VB final in the y plus VA final in the y. Now there's more zeros because they told us that the mass B is going only in the y direction. Okay, so that means that it doesn't have a final x. And mass A did initially have an x. So we know that VB initial in the x equals VA final in the x. So we just figured out that the initial velocity of B will equal the final velocity of A in the x direction. And if we look at the y equation, we know that the velocity of B had no y component, so we know that VA initially in the y will equal VB final in the y plus VA1 final in the y. Now, this is where some of you guys would get stuck, because you're thinking, well, this thing could bounce and you could have a negative velocity for A in the y direction, and B would have a more positive B velocity, which would still have a conservation of momentum. That statement's true. You would still have a conservation of momentum, but that is impossible to occur if you're dealing with similar masses. Okay, so these masses are the same. They're identical. So that is impossible to have happen. In the slides, when we first talked about collisions, I showed you a few scenarios where you had a white and red billiard ball and they were the same mass. When the red billiard was moving and hitting the white billiard that was at rest, the red billiard then would be at rest and the white billiard would have the velocity that the red billiard had before. The reason for that is because they were the same mass. So all that momentum is transferred into the other sphere. Same thing's happening here. Now, you might be thinking, oh, but they're not at rest. As far as the x coordinate is concerned, MA is at rest. It has no velocity, no momentum in the x direction. So when MB strikes MA, all of the momentum in the x goes into MA. Alright? You can see the proof of that right here. That's what this is telling you. Okay? Now, if that made sense, if you had connected that, you would then be able to rationalize that MA has momentum in the y direction, but MB does not. So it would have the same situation where all of the momentum of A initially goes into B at the end. So they end up trading momentum. If they're trading that momentum because they have the same masses, that also means that you can just say they're changing, the velocities just change. Okay, so you could answer this conceptually. You'd be able to say, okay, VB final is going to be a positive 2.0 meters per second. VA final is going to be a positive 3.7 meters per second, and you would need to write horizontally because that's for direction for A. And the sentence would basically be, if MB has only momentum in the y direction, then MA must have all the momentum MB had in the x direction before the collision. Because the masses are identical, the momentum of MB went into MA and the momentum of MA went into MB. So you're basically just explaining they switched. Okay, so mainly a conceptual question. You will be able to prove that this always happens when we go into conservation of energy, and I will be making you guys prove this with the Newton's cradle. So if it was a conceptual question you didn't quite understand, you will understand that after the energy unit, and you'll have the mathematical knowledge to be able to prove it if you can't rationalize it. But it should make sense to you. All the examples I've shown you in the classroom where they actually bounced off, they were different masses because it's the only way it will work. Um, so that's it for this problem, and hopefully you feel prepared for your test.